Okay, so good day sa lahat. So, tapos na yung midterm natin. This is the fourth chapter. Okay, yung fourth chapter natin, we will focus on two-dimensional muna. Okay, so we are down on the equilibrium. This equilibrium, para lang din siyang resultant force except that yung pinaka-resultant natin is equal to 0. Okay? So, for this one, we will focus on what you call the coplanar. Okay? When we say coplanar, it is into two-dimensional. For example, tayo, we have it the three-dimensional. Let's say we have here the x, the y, and then the z. Okay? Or, hindi, baguhin natin. We will be having x, y, and then we have the z. Okay? Ngayon, when I say coplanar, all the forces lies on the same plane. Kadalasan yung binibigay sa atin, nandito yon sa plane ng x and y. Okay? So, nandyan lahat ng forces. Example, dito sa pinaka-problem natin dito, okay, bigay ako ng isang figure. For example, this figure, okay, para siyang nakalagay dito. Okay? So, yan, meron nakaganon, ganyan. Okay? So, it means lahat ng forces mo, it is parallel to the y or parallel to the x. Okay? Wala tayong force na parallel dun sa z. Pag kasi nagkaroon ka ng force na parallel dun sa z, and then it is not anymore a coplanar force system. Okay? Three-dimensional na siya. Ang tawag sa mga forces that lies on the same plane are called the in-plane forces. Okay? Ngayon, yung force na perpendicular dun sa plane ng xy, which is the force parallel dun sa z, ang tawag sa kanya is out of plane. Okay? So, we will focus today on the equilibrium under the coplanar forces. So, mostly gagamitin lang natin sa chapter na to is yung plane ng xy. Kung paano tinuro sa physics nyo before, parang ganun lang din dito, no? Okay. Now, we will be having the coplanar equilibrium analysis. Okay. So, ayan, pwede nyo sagutan. Dito tayo sa lesson proper. When we say equilibrium, it means under the external forces, hindi gagalaw yung isang bagay. Ibig sabihin, it is at rest. Okay? Or if you are on the dynamics, pwedeng gumagalaw yung bagay at a constant, okay, speed. Pag in-applyan siya ng force, constant pa rin yung speed niya. Okay? Parang sinasabi ni law of inertia, nasabi ni law of inertia, a body remain at rest or moving at a constant velocity unless otherwise acted upon by external force. Okay? Now, if na-apply ng external force at hindi pa rin gumagalaw yung bagay or wala pa rin nangyari dun sa system, and then we could say that the system is in equilibrium. When we say equilibrium, lahat ng forces natin, summation ng forces, lahat ng summation ng moments should become equal to 0. For a two-dimensional, okay, balikan natin, mayroon tayong tatlo, di ba? We will be having the direct force, Fx, Fy, Fz, and of course, the moment, okay, double-headed arrow, Mx, My, and then you have also here the Mz. Basically, if we are speaking with the coplanar equilibrium analysis, itong dalawa na to, automatic na x yan. Okay? So, what we will be having here is just equal to, mali ako ng control Z ko. Okay? Ano yung mga hindi kasali kapag coplanar? Okay? Sabi natin, lahat ng forces na parallel sa x and y kasama. So, ibig sabihin, we will be having here Fx. Okay? We will be having here summation Fx para maging equilibrium equal to 0. Ano pa yung parallel dun sa y? So, you will be having here summation forces y equal to 0. Okay. Now, how about the mx? Paano ba yung mx? Yung mx kasi, siya yung magpapaikot doon sa x-axis, ano? Okay. Natatandaan nyo yung lesson sa chapter 2 and 3. Okay. Pwede kong gawin, kung ito yung mx ko, papaikutin niya ng paganto yung aking axis. Okay. Kung gagawin ko siyang force or couple, okay, for example, couple, okay, let's say ito yung line na yon, ito yung x. Papaikutin ko ng paganto yung aking force. Pwede kong i-replace tong couple na to ng isang force sa taas at isang force sa baba. Okay? And they are separated by a distance d para maging moment. Okay? But as you can see, this force is actually parallel dun sa aking z. Sabi natin kanina, if you are speaking with the coplanar, we are only dealing with the in-plane forces. Since yung F natin is parallel sa Z, it means yung MX natin hindi siya kasali. Okay? Dahil it will create a force parallel dun sa Z, or it is a force what you call the out-of-plane forces. Okay? So, sa equilibrium pala ng coplanar forces, hindi kasama si MX. How about si MY? Kasama ba si MY? Let's see. Si MY naman, I'm sorry, medyo may sama pakiramdam ko. Okay? Si MY naman, papaikutin niya ng paganto, no? Okay? X, Y, and then Z. Sorry. Papaikutin niya ng paganon. Okay? Ngayon, para maging, sabihin na natin, okay, para maging tawag dito, couple siya, para ako merong force dito, at saka meron akong force doon, na force, and then force, kunin ko equivalent, separated by a distance d, okay, para mag-create ako ng couple. Kaya lang, itong F natin, it is parallel to the Z axis. In short, to create the MY, kailangan natin ng force parallel sa Z, which is an out-of-plane force. Eh sabi natin, kapag coplanar forces, hindi kasama ang out-of-plane forces. In short, si MY hindi rin kasama sa equilibrium. Lastly, we have the MZ. To create the MZ, again, para kang, sabihin na natin, iikot kasi yan ng paganon, meron kang force dito, sorry, pangit yung ano. Dito na lang. Okay, let's papaikutin natin pa ganon. Meron kang force dito, and then meron kang force doon. Okay, and then they are separated by a distance d. This F, saan parallel to? Parallel siya dito sa aking x-axis. So, kasama siya. I will have it summation moment z equal to 0. Okay? Nung kaya ay physics, lagi lang yan summation m equals to 0. Alam nyo na yun eh. Kasi two-dimensional eh. Pero actually, in reality, it is called the MZ. Summation forces x, summation forces y, and then summation moment at z. So, in an equilibrium of coplanar forces, we are dealing with these three, okay, units. So, summation forces x equals to 0, summation forces y equal to 0, and then summation moment z equal to 0. Then the rest, summation forces z, summation moment x, summation moment y, hindi na natin siya kino-consider. Automatic yon equal to 0. Okay? Now, going back. In short, meron lang tayo for an, sabihin na natin, for an equilibrium of coplanar forces, meron tayong tatlong equation. Ito yun. Okay? This is actually MZ yan. Palagi ano? Ngayon, kung meron ka lang tatlong available equations, dapat the maximum unknown for a given system should also become equal to 3 maximum. Pag naging 4 na yan, hindi na natin siya kayang isolve kaagad. Gagamit tayo ng ibang techniques. Okay? So, to define first the free body diagram, ginagawa na natin yan, ano? So, we try to have the external forces on the body. Pag tinanggal natin yung support, papalitan natin siya ng forces. So normally yung mga supports, ito yung mga roller and yung mga pin and then fix. Okay? To review, pag sinabi kong roller, isa lang yung unknown. Palagi siyang perpendicular dun sa plane. Pag fix siya, pag pin siya, laging dalawa. Pwede kang summation forces X and then summation forces Y. Okay? Kapag fixed naman siya, tatlo na yung unknown. X, Y, and then of course, the moment at Z. Okay? So, you may read it. I will send you this one. Okay? Excuse me. So, meron tayong additional, which is the support, which is the cable. Yung cable, para siyang roller. Okay? Lagi lang siyang one unknown. Except that yung line of action ng force niya is palaging parallel dun sa direction ng cable. Okay? Pag sinabi nating frictionless surface, it means para siyang roller. Okay? Frictionless. Wala siyang force. Okay? Wait. Kung ito yung surface mo, okay? Para siyang roller na ganyan, palagi lang siyang perpendicular dun sa ating surface. Okay? Surface with friction, palaging dalawa. Para naman siyang pin. Pag may friction, of course, dalawa na yung unknown mo. Okay? Pag pin support, dalawa yung unknown. Okay? Ito yung cantilever para tong fix. Okay? So, it means, fix yung support niya, tatlo siya. Isa-isahin natin, flexible cable, isa lang yung unknown niya. Okay? Para siyang, let's say, ito yung cable mo, pag ganyan lang din yung force. So, you have here one unknown. Frictionless surface, one unknown, palagi lang siyang perpendicular. Same thing with the roller, para siyang roller support, one unknown ng lagi. Okay? With friction, isang perpendicular at isang parallel. So, we have two unknowns. Yung pin support, okay, palagi siyang dalawa. Isang horizontal at saka isang vertical. So, you have two unknowns. Excuse me. The difference with D and E, yung pin support, pwede mo siyang i-consider palagi as X and then Y force. Yung surface with friction, palagi naman siyang perpendicular and then parallel. Okay? So, ito, yung cantilever, para siyang laging ganyan nakafix. So, meron kang vertical, meron kang horizontal, and then meron kang couple or meron kang moment. So, this one, you have 3 unknowns. Okay? So, ito siya. Ito mga different types of supports. And then, their FBDs. Yan. Tension. Surface. I guess this one is roller support. This one is with friction. Pin support. And then you have your cantilever support or the fixed support. Okay? Example. The homogeneous 6-meter bar AB is supported in the vertical plane by A, rollers at A, and B, and a cable at C. The mass of the bar is 50 kilograms. Draw the FBD of bar AB. Determine the number of unknowns on the FBD. Ito na kagad yung solution nun no? Yung weight, kaya natin ibigay, no? When we say homogeneous, exactly at the center ng member doon nag-act. So, ito yun. Alright? Now, yung cable, sabi natin, that is one unknown, lagi siyang pahila. Okay? Kung tinanggal nyo siya, okay, let's say, pinutol nyo dito, tinanggal nyo yung support na yun Tatanggalin ko yung cable, papalitan ko siya ng force. So, yung force niya mula doon, papalayo. Again, that is one unknown. Okay? This roller, eto kasi yung surface niya, laging perpendicular. Another one unknown. Yung B, roller din siya, perpendicular yung kanyang force. So, another one unknown. So, the total unknowns, 3 unknowns. Kung meron kang 3 unknowns, pwede kang mag-summation forces X, summation forces Y, and summation moment Z. Meron kang 3 equations, 3 unknowns, this problem is solvable. Okay? So, sa ngayon, i-determine lang natin yung kanyang number of unknowns. Okay? So, ito siya. So, ang tawag natin doon is the normal reactions, no? Yan. So, tatlo yung unknowns natin. Although, 4 yung forces natin, pero 3 lang yung unknowns. Kasi yung isa, yung weight, kaya natin siyang isolve. Okay? How about this one? Okay. Titignan lang natin yung buong figure, ano? Okay. So, tatanggalin ko lang yung support dun sa A. Okay, for example, ayan yung body natin. Okay, may moment ka doon, may force ka doon. Tatanggalin ko yung support na pin. Papalitan ko siya ng force. Ilang force? Since this is a pin, you have 2 unknowns. 1 and then 2. So, meron kang 2 unknown. Ito yung Fy, ito yung Fx. Dito, lagi lang normal reaction. So, you will be having here 1 unknown. So, you have here E1. Okay? So, 2 plus 1. You have 3 unknowns. It means solvable yung problem. No? Kaya natin siyang sagutan. Okay? So, ayan. So, ito, practice problem. I-determine nyo kung ilan yung unknowns. No? Yan. Determine the result. Given P1 equals to I guess this one is not mali yata yung figure. Okay. Okay. So ito, hindi muna tayo magbabaklas naman kasi pwede natin siyang baklasin eh. I-try lang natin. So meron ka ditong pin, ilang unknowns to? 2. Ito ilang unknowns? 2 din. So 4 unknowns. So tingnan natin kung solvable na. Pero hindi dun makikita eh. Kumbaga, kapag yung isang bagay, okay, hindi siya connected by the pins. Ang tawag kasi natin dito composite eh. Pero darating tayo dun, ano. So sa ngayon, ang pag-uusapan natin is yung outside reaction. External reaction, what I mean is external reaction. Okay, eto yun. Yung mga pin na nagko-connecta dun sa mga members, example, itong member AD, member BE, and member CE, 3 yung members niya, di ba? Para siyang pinagkabit-kabit. Okay? Kung paano siya kinabit sa kada member, for example, itong AD, ikinabit ko sa BE, may pin ako doon. So, meron din yung reaction. Ang tawag doon sa reaction is internal reaction. Yung internal reaction, siya yung mga reaction na nagko-connecta sa dalawang magkaibang members. Okay? Hindi katulad nito. Isa lang yung sinusupport niya, di ba? Itong member lang na to. So, this one is called external reactions. Pero itong mga pin at this point and that point, it is called the internal reaction. Okay? So, that is for the introductory. So, we will proceed with this one, with the coplanar equations for the general case.